hypothesis testing. Before we get into the language of hypothesis testing, we would want to know what a hypothesis is about. Well, in statistics, a hypothesis is made about the value of a parameter. So that value, that parameter could be the mean, mu, proportion, p. Some example hypotheses would be, someone might say the population mean mu is not equal to 7. The proportion is not equal to 0.5. The proportion is greater than 0.5. The population mean is less than 0.29. So all of those are hypothetical statements that we make about the population parameter. So once we have the hypothesis set up, we will verify the hypothesis using the sample. So the basic setup of a statistical test consists of two pieces. So this is the setup. You have two parts. One is the null, the other is the alternative. It's pronounced as H naught, as naughty, so H naught, and the other is the alternative. Hypothesis. That is how we set it up. So in the null, we say that the parameter value is equal to some number. And the alternative could be one of three things. So it could either be parameter not equal to the number that's in the null, or parameter is greater than some number, or parameter is less than some number. So those are three possibilities, and we would pick one out of those three in a problem. Typically, the problem says, has a hypothesis, it's greater than something, we would pick option 2. So we usually pick one out of those three, but the null, it's always parameter equals some number. As an example, mu, which is the average BAC of drivers, involved in fatal crashes. And the claim that the average is bigger than 0.15. So what we have here is the claim statement, and the sum number that I was talking about in the definition is what we have here as 0.5. So in this case, based on the claim statement, the null is mu equals 0.15. The alternative mu not equal to 0.15. Oh, sorry, greater than 0.15. So the objective is to determine significance. So if someone said, oh, we have 1.16, well, 0.16 is definitely bigger than 0.15, but that is from a mathematical perspective. Since we are dealing with random samples, we want to know, is it significantly larger than 0.15? Is 0.16 significantly larger than 0.15? So the goal here is to assess significance. When we say that a number is bigger than, we want to know, is it significantly bigger? If it's smaller than a value, is it significantly smaller? And that is the goal. So with population proportions and means, I'm just going to make a direct comparison. The null would be P equals P sub 0, P naught. The alternative, P not equal to P naught. Case 2, P equals P naught. P greater than P naught. Case 3, P equals P naught. P less than P naught. For mean, mu equals mu naught. Mu not equal to mu naught. Mu equals mu naught. Mu greater than mu naught. Mu equals mu naught. Mu less than mu naught. So those are the three different types of tests for each proportion in proportions and means. Now, P naught is the value that is claimed in the hypothesis. Likewise, over here, since it is a mean, it is the same, but we use a different notation. So mu naught, because we're talking about means, so mu naught is simply the value claimed in the hypothesis. The first case that you see is what we call a two-tailed test. The reason, because if you want to test that something is not equal to something else, then you have to look on both sides to conclude that it is not equal. But if it is greater than, we call it a right tail test. We only look at the alternative to determine if it is two-tailed, right-tailed, or left-tailed. Since the alternative has a greater than, we call it a right tail test. If the alternative has less than, then we would call it a left tail test. And those two combined together are one-sided tests. So you either look on the right side or you look on the left side. So those are one-sided tests. So you can either call them as right-sided or right-tailed, left-sided or left-tailed. So when we have a problem, we have to read the claim statement properly, understand the value of P naught, and write these statements out. Usually it's going to be one out of these three, depending on the problem. You just have to get that from the problem. And once we have the setup ready, then we can proceed with a proper test. Our objective in hypothesis testing is to test for the alternative. So note, we have a setup. Our setup is we have a null hypothesis. And we have an alternative hypothesis. So the null is what we call no effect. Null means nothing, so no effect whatsoever. And the alternative simply means there is some sort of an effect. That's what we call true effect. A clinical example. No effect means no disease. True effect, tested positive for disease. So our objective is to always test for the alternative. Is there an effect? Is it significant? What is the sample telling us? Is the sample telling us that there is a significant effect toward a significant effect, or is it some support toward the alternative hypothesis? So we're always testing for the alternative. So the claim statement will be in the alternative. Just because we have a statistical test, it doesn't mean that it would always be correct. Sometimes a test could go wrong. So that's where the value alpha comes into play. This is something we have seen before. It is the level of significance. But in the context of hypothesis testing, this is the probability of type 1 error. Or it is the probability of a false positive. What do I mean by type 1 error? What do I mean by a false positive? We've got to construct a table to understand that. So So the reality or the truth has two possibilities in the context of hypothesis testing. So you either do not reject the null, or you reject the null. The test also has two possibilities. The test would either conclude do not reject null, and you reject null. We can say not rejecting null in a clinical perspective or from a clinical perspective as a negative. Rejecting null is a positive. So if the reality is to not reject the null, and your test also concludes that you don't reject the null, you are right here. So the reality is a negative. Your test concludes that you have a negative. So if that is the case, there is no error at all. In reality, you are negative. You should not be rejecting the null. But if the test concluded that you're positive or you rejected the null, then you're making a mistake. You concluded that we have to reject the null or that is something is positive, when in truth it is not positive, it is negative. So that is what we call type 1 error, which is the same as the probability of a false positive. If the truth is that you have to reject the null, that something positive is going on, but the test gives you a negative result and you conclude do not reject null, then the truth or the test is in disagreement with the truth. They contradict each other. The truth is that you should reject the null, but in reality it says do not reject the null. So there is an error, and this is what we call the type 2 error. And that's what we call the probability of a false negative, because in truth, you should reject the null. It is positive, but the test concludes you are negative. So in fact, there happened to be a false negative. We made a mistake. Hence, that particular error is called a type 2 error. If the truth is that you have to reject the null and the test agrees with the truth, then there is no error at all. So in practice, what we try to do is a researcher So a researcher or a practitioner will typically fix the value of type 1 error at a predetermined level prior to conducting the test. The typical levels are, for example, alpha could be 0.1, 0.05, or 0.01. So in each case, the maximum probability of error that we can tolerate is, for example, 5% or 10%. We all know 0.05 is the most commonly used level. Very similar to what we did with confidence intervals. 95% confidence intervals are the most common one. So alpha equals 0.25 is the most commonly used level. So in the problem that we have here for packaging and labeling, we have to determine the null and alternative hypothesis and explain what it would mean to make a type 1 error and explain what it would mean to make a type 2 error. So federal law requires that a jar of peanut butter that is labeled as containing 32 ounces must contain at least 32 ounces of peanut butter. A consumer advocate feels that a certain peanut butter manufacturer is shorting customers by underfilling the jars. So the advocate is making a claim. So let's just say, we'll start with H1. The advocate's claim, so the amount is less than 32 ounces. That's what the advocate is claiming. So the null has to be the opposite of the alternative. So the alternative is less than, so the null should say it is greater than or equal to 32 ounces. Now, instead of saying greater than or equal to, some textbooks would simply rely on amount equal to 32 as the null. And that would align with our definition. So here, the claim made by the advocate is in the alternative. The value claimed, let's just say claimed value is 32. And we want to know if there is any value or any truth to what the consumer advocate feels. So the consumer advocate is the person who's going to do the test. So the consumer is not underfilling, the company, or the company is underfilling. Those are the possibilities. So the alternative, if you rejected the null, we're going to say they are underfilling. Otherwise, if you don't reject the null, they are not underfilling. So the advocate does this thing, which is the statistical test, not underfilling and underfilling. So that's what the consumer advocate does. So he's doing, or they are doing a test to determine whether the company is underfilling or not underfilling using our setup here. So not underfilling would simply mean you do not reject no. Underfilling would mean you reject no. So if the company is not underfilling and your test also concludes that you're not underfilling, then there is no error. If the company is not underfilling, but you conclude, the customer advocate concludes that the company is underfilling, then you're actually accusing them that they're underfilling when they are truly not underfilling. So you made a mistake. So here you made a type 1 error. You're falsely telling that they are underfilling. If the company is underfilling, but the consumer advocate performed the test and the test concluded, oh no, the company is not underfilling. The consumer advocate made a mistake, and that would be a type 2 error. In other words, it's a false negative. So in truth, the company is underfilling. The consumer advocate simply failed to not capture that the company is in fact underfilling. So that's a type 2 error. If the company is underfilling and the consumer advocate performs the test and determines that the company is in fact underfilling, then there is no error. And that's how you determine the type 1 error and type 2 error scenarios. But you should always make sure that you are clear in coming up with the definition or the setup. So I started with the alternative. That is the claim. Typically, we test for the claim. So the consumer advocate's claim is that the amount is being shortened. So it's less than 32 than what it's claimed on the label. So I started with the alternative, then went to the null, and that is the proper process. So in 2014, the standard deviation of that score on the critical reading test for all students taking the exam was 112. So a teacher believes that due to changes to the high school curricula, and that is the effect that was introduced, the standard deviation of SAT math scores has decreased. Let me just use the notation for standard deviation. Sigma SAT score, the standard deviation of SAT score is less than 112. In other words, it has decreased from 112. That is the claim made by the teacher. And what caused that claim? That would be the effect. The effect is change in curriculum. The null is the opposite of the less than sign, so it's greater than or equal to, or you can simply write it as But it depends on, those are just variations. By all means, the one on the first line, the standard deviation of the SAT score greater than or equal to 112 for the null is more formal when compared to the other option. So that would be the definition. So do not reject null, reject null. Same here, do not reject null, reject null. Reality, and whatever the teacher conducted as a test. So do not reject null simply means the SAT score standard deviation did not decrease. If we rejected, the standard deviation decreased. Same thing. If the teacher's test concludes that you don't reject a null, then the standard deviation didn't decrease. Otherwise, it decreased. So in reality, if the standard deviation didn't decrease, and the test also concludes, do not reject the null, standard deviation didn't decrease, then there is no error. But in reality, if the standard deviation did decrease for the test scores, then we should reject the null. But the test that the teacher did concludes do not reject the null, then you committed a type 2 error. Sorry, that's a type 1 error. And in reality, you shouldn't be rejecting the null. Oh, it is type 2, my bad. In reality, you shouldn't be rejecting the null. In other words, the SAT score didn't decrease, but you end up saying, oh, I'll reject the null. The SAT score did decrease. Then you made an error, and that would be type 1 error. If the truth is that the standard deviation of the SAT score doesn't or didn't decrease, and the teacher comes to the same conclusion and, matches with reality, then there was no error made by the statistical test. So there is no error.